Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad IZZUDIN Muhammad BAKRI. Number metric AA200475. Today I will talk about introduction. Torsion refer to the twisting of the straight bar when it's loaded by a movement or torque that tend to produce rotation about the longitude axis of the bar. The effect of primary concern in the design of a driveshaft use a vehicle and machinery, and for this reason it is important to able to determine the stress and the deformation of the occur in shaft when it is subject to torsional stress. When the torque is applied, the longitude green line originally marked on the shaft tend to distort when dissolved into a helix. The intersect the circle at equal angle. Also, all the cross section of the shaft will remain flat and they do not warp or bounce in or out. Okay, next is driveshaft. The driveshaft, also called propeller shaft or prop shaft, is a component of the drive train in a vehicle with the purpose of delivering torque from the transmission to the differential, which then transmit this torque to the wheel in order to move the vehicle. The driveshaft is primarily used transfer torque between components that are separate by a distance. Since different components must be in different location in the vehicle. Driveshaft are used differently. Vehicle varying greatly in car with distinct configuration for front wheel drive, four wheel drive, and the previously mentioned front engine rear wheel drive. There are three types of driveshaft commonly used in vehicle, which is single piece shaft, 2 or 3 propeller shaft, and front wheel drive FWD.
Hello, my name is AIMAN NIZAM. So I'm going to continue for methodology. So this is methodology for material selection for drive shaft. So there are few materials that normally used for making hollow shaft and solid shaft in the industry. So solid shaft and hollow shaft are both employed in numerous vehicles such as car, buses and trucks. So there's few materials that have been used for drive shaft, such as stainless steel. So stainless steel, which is SM45C, is a high quality quench and tempered carbon structural steel. It belongs to the high quality low carbon chromium, molybdenum, nickel case and hardening steel. So the other one is aluminium alloy. So it is a precipitation hardened aluminium alloy with the major alloying elements magnesium and silicon. It has strong mechanical qualities and easy to weld and also often extruded. So the last one is titanium alloy. It has strong strength and characteristics that are incompatible to those of the cytotoxic vanadium containing alloy. So it's composed of hexagonal paste with aluminium and a typical body centered paste stabilized with niobium. So we're going to look to method of selection for drive shaft. Number 2, material properties. Number 3, design of solid shaft and hollow shaft. Number 4 is the design comparison between the solid shaft and hollow shaft, and the last one is model analysis of the solid shaft. So material properties, still SM45C has been chosen for the shaft material. The material is classified as AE1045 according to SINGH standard. The carbon content of this substance range from 0.42 to 0.48%. So in the manufacture of propeller shaft, is the most used and preferred material. So the primary goal of shaft is to determine the stresses that rise at a crucial point in the shaft because of the load, as there is a spinning component that support rotating wheels but does not transmit torque. So the fourth one is design comparison between the solid shaft and hollow shaft. So the fundamental goal of both design is material optimization. When they are compared, the mass of the hollow shaft is substantially less than that of solid shaft. So mass of the solid shaft automatic propeller shaft is found as 6.12 kg. Mass of the hollow automatic propeller shaft is found at 4.68 kg. And the last one, the total mass of 1.44 kg is being reduced from solid shaft to hollow shaft. So advantages of hollow shaft over solid shaft. Advantage number 1, hollow shaft has more strength than solid shaft for the same weight. Number 2, with same weight, the rigidity of a hollow shaft is greater than the solid shaft. Number 3, with the same weight, the natural frequency of a hollow shaft is higher than that of solid shaft.
A very good afternoon. My name is Taranjit Singh, Lucky BAHJAN Singh, with metric number AA 2002-18, and now I proceed with the analysis and discussion of the driveshaft. As an engineer, after thorough research in material selection of a product analysis, calculation should be done to ensure compatibility and suitability of the respective product in the engineering field. In this project, analysis and discussion is done on the driveshaft of a selected automotive vehicle, which is Proton Saga 1.3 litre standard engine. These are the specification of the transmission of driveshaft of the engine to compensate with the suitable selection of the type of driveshaft that should be chosen. First of all, the Proton Saga 1.3 litre standard MT consists of 4-cylinder engine inline with 16 valve DOHC WVT, and the transmission is 5-speed manual. It has max power of 70 kilowatts. The engine displacement is 1332 cc, and the max revolution of the is equals to 500 revolution per minute. Okay, based on the methodology and the material selection, SM45 steel is the most suitable material that is to be chosen for the driveshaft of the Proton Saga 1.3 litre standard MT. Why? This is because the material contains a carbon percentage between 0.42 to 0.48%. The steel is widely used and most preferable material in manufacturing the propeller shafts or drive shafts. And also, SM45C steel is a high-grade steel which avoids rapid failure in the drive shaft. The high-grade steel has high strength to withstand tensile and compressive load. And now we will proceed to the calculation part of the drive shafts. Okay, in this case, we will choose the comparison, the best suitable drive shaft between a solid shaft and a hollow shaft. For that, we need to do a certain calculation, finalize or to improve our design structure. Okay, so from the first question, the Proton Saga 1.3 litre standard MT engine produces 70 kilowatts of power from the engine. Power is then delivered from the transmission to the differential of the car wheel. The revolution of the shaft is 500 RPM, which is the maximum. The diameter of the shaft is set at 40 mm, and the maximum shear stress is to be determined. So first of all, how we analyze is that first we need to convert power of in kilowatts into Newton meter per second. So as we can see is that by using the formula, we converted into 70,000 Newton meter per second. Next, we have to convert the revolution in RPM into rads per second. From the formula there, we get 52.36 rads per second. Next, using the formula of power is equals to torque times by revolution, we can find the value of torque, which is equals to 1336.90 Newton meter. Applying the formula of shear stress is equals to torque times by the radius divided by the J value. So we can find that the maximum shear stress of a solid drive shaft is 106.40 megapascal. For the second question, it is the same thing, but it consists of a hollow drive shaft with an inner diameter of 20 mm and outer diameter. The same analysis from a solid drive shaft is then converted into the for hollow drive shafts. So as we can see, by applying all the formula above, we get the maximum shear stress of a hollow drive shaft is equals to 113.49 megapascal. For the discussion part, based on the theoretical calculation for comparison of shear stress in solid shaft and hollow shaft of the same type of material, which is SM45C steel, it can be proven that the hollow shaft has higher shear stress compared to solid shaft. Next, the hollow shaft is the most efficient design in transmitting torque to the differential of an automobile system. The hollow design has higher strength to weight ratio compared to the solid design, which reduces the unsprung weight of a vehicle and its inertia. From the analysis and calculation, it also can be concluded that with the same type of material and the same weight, the hollow shaft has more stiffness than the solid shaft. The material at the center of the hollow shaft is removed to spread out at large radius. As a result, the hollow shaft are more durable than solid shaft of the same weight. There are few primary reasons that lead to failure in drive shaft. So there are few ways to overcome the failure of the drive shaft also. Okay, one of the major failure in drive shaft is that improper assembly, which prone to fracture under specified operational shear force. Why? This is because probably there are some minor defects in the drive shaft assembly process. So how to overcome it is that we have to do a proper designing. Engineers have to do a proper designing process whereby they should initiate a proper simulation test using SolidWorks to determine any defects in materials. Another major defects in drive shaft is that improper manufacturing process in terms of heat treatment that fails to achieve certain desired microstructure that can decrease the stiffness, hardness, and also the thermal resistance of drive shaft. So sometimes this heat treatment process is not carried efficiently, whereby it involves man work. Sometimes this man work process will have some types of errors in doing the heat treatment process. How engineers should overcome these things this process is that they should apply correct technique of heat treatment and quenching process when manufacturing the drive shaft. Engineers can utilize specific technologies that will carry out heat treatment process with the aid of artificial intelligence to reduce the minimal error. The third and final failure in drive shaft is that it is due to continuous cyclic overloads and stress concentration, which can increase the failure percentage in drive shaft. So why this is probably due to the position or the assembly process of the drive shaft. The drive shaft is not placed at the correct angle, which can result in maximum cyclic or stress during the rotation process of the drive shaft. So how engineers should overcome this is that the position or the assembly process of drive shaft in an automotive vehicle should be precisely noted to avoid cyclic load or stress concentration on a unit area to avoid failure. The angle of twist, displacement, weight ratio, and shear stress distribution should be analyzed first before the assembling process of the drive shaft.